looks good on LinkedIn. Not seeing it on YouTube yet. Really enjoying life last. Oh, cool. Okay, so yeah, sorry guys. I'm still getting used to this. For the first 4 minutes are just me talking to myself, basically. Hopefully everybody can hear me talking to myself. I know we had this minor issue with the volume last time. So I'm just checking, making sure the chat is up here. Oh, that's interesting. So I can only read the messages from LinkedIn for now. I can only respond to the ones on YouTube. There's about a 30-second delay. Eventually I can change that, but I'm just kind of leaving it on like the default settings, which is about a 30-second delay. So when you send a message in, it takes me a minute. I might be doing something else, so I can't get to it immediately. Okay, so let's get started here. Let me know. I've got this like minor background music. Let me know if it's bothering you. I can kill it. I know everybody has their own feelings about background music. I'm trying to incorporate it to the extent to where I'm talking, the background music will or when I'm not talking, when I'm just writing or something, the background music would turn up and just give you something else to listen to besides static. So I'm not quite there yet. Now it's just playing at a steady state volume the whole time. I'm gonna check messages over here real quick, and then we'll get started. Okay, so for today, in the chat, let me know if something's up, if you can't hear me, or if you can't see something. I think I did remember to take I think last time I was talking for 15 minutes with the with this over my face, so remember to remove that for you. So today, what I want to cover here, a couple topics. Make sure. Let me get this back. Oh, great. So let me end that slideshow and then start it again. So I've got a couple drawings similar to last time that we can go over, but the first thing I wanted to talk about was I got this question in email. I thought it was a great question. How do I convert my plus or minus or my coordinate tolerances to position? So here's an example. This is a drawing I found in a great textbook. It's a jig and fixture design. I think it's Delmar as a publisher. Great little textbook, lots of handy information. But let's say we're going to locate one of these holes, right? What we have here are plus and minus dimensions for the location. In this case, in the top one, it's a little confusing because we've got a plus or minus 5 for the left and right dimension, and then they've let it go to title block for the up and down dimension. And I know it's behind me, but just trust me. The title block is also plus or minus 5,000, so not really sure why they did it that way. But, who am I to judge? Then the hole is going to have its own tolerance of some value. I'm not blanking on what that's actually going to be right here. Where is it? If anybody sees this diameter, please shout it out, or I'll just give up. Yeah, oh well, whatever. This counterbore diameter will have some kind of tolerance. So the question in the email is like, which one do I use, right? So I'm going to convert this to GD&T stuff. Which tolerance do I use? Do I use these from the location, or do I use whatever the tolerance is for the diameter of that feature? And it turns out it's gonna come from the tolerance on the location, as you might imagine, but it's not a one-to-one thing. So we can't just take plus or minus 5 thousandths and put that in the feature control frame. So what I mean is we can't just do this, right? This doesn't mean the same thing as a location of plus or minus 5 thousandths. That's not going to work for us. And I'll show you why in just a second here. So that's what we're going to cover. So in order to show that, I really need to kind of derive the position. I don't want to call it a formula, but you know, how we calculate position. So let's take a very simple spot right here. We'll use the simplest possible part. Right, we're going to have these basic dimensions. We're going to have datums. And this drawing is going to be slightly incomplete, so don't screenshot me. It's just right, nice and simple. So we got basic dimensions. Doesn't matter what the actual number is because they're theoretically exact, right? They're perfect. So there's no variation on that. So we've got datum A as a surface parallel to our screen because we have this leader with the filled in dot. Datum B is horizontal. Datum C is vertical. That gives us the origin for our measurements right in here. Okay. With position, when we use GD&T, that gives us a little round tolerance zone right in here. Now I want to contrast that to the exact same part with plus or minus dimensions. So with the plus or minus dimensions, I am going to give it a tolerance. Right, so we're gonna, in both cases, I don't care what the diameter is or what the tolerance on it is. So in this case, right, with this plus or minus dimensioning scheme, the tolerance zone is not going to be a circle or a cylinder. It's going to be a square. Right? And I hope we can kind of see that. You've got your variation left to right. It's 20 thousandths. Variation up to down is 20 thousandths. So you end up with a square in the middle of the part. And for some things, that's basically fine. You know, like some flat, like sheet metal-y parts, it really don't matter that much. As parts get thicker, position starts to matter more because position is going to have an influence on the perpendicularity, whereas the plus or minus really, it's difficult to do that without complicated notes. Okay, let's take a look at this tolerance zone, right, or coordinate dimension tolerance zone. So we're saying we've got this square that's plus or minus 20 thousandths. So the square is basically 40 thousandths, right? And at the center is where we'd really like the center of that hole to be, right? And I know those of you that have taken like a GD&T class have definitely seen this before and probably had it explained before. But those of you who haven't, this is a good way to kind of see what's going on. All right. So say we make a couple of these parts and the center of the hole is in a couple of different locations, right? Marked by these little X's. So the first location, let's say we have a hole and we measure and it's right at this edge, right? Plus 20 thousandths in the Y, 0 in the X. That's going to be, you know, acceptable, right? No big deal. Same thing. If we measured over here, that would be acceptable. We're just plus 20 in the X, 0 in the Y. And we'd be okay if we have a hole in this corner, right? And that distance is going to be greater than 20 thousandths. And most of you probably already see this, right? We have a little right triangle, right, with 20. And if I can remember right, the hypotenuse is 28 thousandths. And that's just going to be Pythagorean theorem. No big deal there. The problem is I could measure a hole, say, down here, right? And it's 28 thousandths away from the center, but in the wrong, well, the wrong direction, basically. So what happens is we have to fail this last part right here because it's outside of the square tolerance zone, but it's the same distance from the center. So notionally, that part would work the same as a part, you know, that has the measured in the corner here. So what we're doing with tolerances of position is we just make this a round tolerance zone, right? We just put a circle, a square in a circle. And that's how we're going to describe a tolerance zone. Now, you can, with position, have a square tolerance zone if you wanted to. It requires that you use 2 feature control frames. You could do a rectangle or a square. There's no support for this, and I've gotten this question before. Wait, can't I just use a, oh, actually, that would be a 40. Like, why can't I use the sweet square symbol of 40 thousandths and apply it to something? You know, I think the main problem with that is it's not clear what orientation the square would be in. Also, there's no documentation, no pictures, no nothing in Y14.5. So you kind of be on your own if you put this on a drawing. You'd really have to explain exactly what you're looking for there. Okay. So this round tolerance zone effect, what happens is when we go to measure a part, and you may have seen my video about this, you know, you're going to measure from the granite plate in each direction. So you're essentially going to measure in the Y direction and then measure in the X direction. When your tolerance zone is a square, your X's and Y's are directly comparable to what's on the print, right? So if I go to measure this part, right, and in this direction I get 1.01, right? I can look at this and say, okay, my maximum is 1.02, my minimum is 0.98. I measured 1.01, we're good, right? You can do the same thing over here. You can say, okay, we measured 0.99, that's greater than the minimum, we're good. And that's all you have to do. As far as inspection, as far as verifying your measurements, which is pretty cool, right? Pretty quick. The issue with position is sometimes you can, just by, you know, looking at it, tell that it's within a square, that's within a circle. But with position, you can have this round tolerance zone, right? You got this square, right? That's your plus or minuses. It's difficult to tell, like, in your head, if something that landed in this kind of no man's land is within tolerance or not without calculating it or graphing it. And then, do I have... Give me 1 second. Oh, sweet. Okay, so I gotta show you guys this. Check this out. I got this from eBay. It's a position computer, right? So I guess this is before calculators were, super common for this. But basically, the way this works is on one side, and let me get this closer to me. So say we measure an X and a Y, and we get 11 thousandths in X and 10 thousandths in Y. We follow this down, and that's going to tell us the diameter tolerance zone that is consumed. And hold on. I can't even read it, so I don't know if you guys can either, right? So we've got whatever this number is. And then we can have any reasonable combination, right? So this is also, so say we measure and we got 10 thousandths in one direction, 5 in the other. We would have a diameter tolerance zone consumed of 0.0224. So see what I mean? Like, you get these measurements, you can't in your head tell if that would be, good with a position of 15 thousandths or whatever, right? You'd have to look at, you have to calculate it. Now, not everybody is going to have one of these things. They are pretty handy though. They're pretty cool. You can use a chart, right? Obviously you can just do this in Excel and have a big wall chart. You could buy them. I mean, they're PDFs and stuff out there on the internet or whatever. We'll talk about, maybe today, maybe I'll have to do it some other time, but we can talk about this as well. The floating fastener, fixed fastener formulas. Same idea, right? These can just be calculated with this sweet position computer, right? Okay. So how do we figure out, right? Say we go to make some measurements, and let me wipe this. Say we make measurements. And this is what we get, right? We we measure our gauge pin. We subtract half the gauge pin, and this is where the center is. So we want to plot this on a little chart. And some of you may have seen this before. I covered it in my position video. So these are the measurements we get. What we want to do is compare each measurement to the true position. So in the center of each of those tolerance zones on a part with multiple features is a true position. So we want to get rid of the basic dimension. So we're just going to subtract, and I didn't put it on that drawing, but let's say the basic dimension is 1 inch, right? And this is going to give us our variation in X and Y. And we can plot this on our chart. So what I would do here, and Y, we're going to be +2, and X, we're going to be -2. So our point would be right here, right? And we want to know if that point, let's just make up, we want to know if that point is within a tolerance zone of, say, 28 thousandths, right? To some datum reference, right? So one way to do it is graphically. All we need to do is set one leg of a protractor in this X, one leg in the center here, and then we can swing it around and just read off the ticks, right? And that'll tell us what the diameter tolerance zone is. And that's a perfectly valid way of doing it. The analytical way, right, to get an exact answer, as you might imagine, is to use Pythagorean's theorem. Right, we're going to find the triangle. We're essentially going to compare one leg to the other leg to get the hypotenuse. So you may remember a squared plus b squared equals c squared. Right. So what does that really mean? I know everybody hasn't been in a math class recently, so it's okay if you don't recognize it immediately. Basically, the one side is a, the other is b, the other is c. So they have to meet this expression, right? A squared plus b squared equals c squared, if it's a right triangle, right? If this is 90 degrees. So what we want to do is rearrange this to solve for one of these, right? We want to solve for c, right? We want to know what that is when we're calculating position, because we're going to know the x and the y. That's what we're going to measure. And we got to figure out what the hypotenuse here is. So easy peasy, right? We're just going to take the square root of both sides, and that's going to cancel out here, right? Square root and exponent cancel out. So we end up with C equals the square root A squared plus B squared. We plug in our handy numbers here, right? And it's okay, right, that it's negative because we're going to square it, right? A number times a number. A negative times a negative is a positive. So we'll put 0.02 here. We'll put 0.02 negative here, squared, add equals C. I know this is going to be 4/10 of a thousandths. This is going to be 4/10. I don't know the square root of 8/10 off the top of my head. I'll have to go to my handy calculator. So that's going to be a diameter of 0.028, right? Which tracks. Oh, I'm sorry. That's going to be a radius. So we're saying this number is 0.028, and I'll explain why that's well, that was cool with that number. What we need for the diameter, we need to double that. Right, we need this, so we're gonna multiply this by 2. Right, so this 0.28 is going to become, I think, 0.056. Yep, 0.056 is going to be our answer here. Now, when you look it up in any textbook, right, you'll see it written as this. Right, 2 times variation x squared plus variation y squared is the diameter. So I did it the drawn out way just to kind of show you that it comes from somewhere. It's not just a equation that was handed down from above. It was just a variation of Pythagorean theorem. Okay, why did that 0.028 seem familiar? Well, you may notice when you're dealing with drawings that you'll often see these numbers in a feature control frame for position, right? 7 thousandths, 14 thousandths, 28 thousandths, and 56 thousandths. Let's start with a diameter of 14 thousandths. It turns out it turns out that a diameter of 14 thousandths corresponds with the square of about 10 thousandths. So if we take this little triangle here, we're saying 5 thousandths by 5 thousandths. Let's actually solve this. I want to make sure I'm right, and I don't. I know I keep saying getting screenshotted, but I don't want to be wrong. So we've got square root of 5 thousandths plus square root of 5 thousandths. That's just going to be 0.0. A bunch of zeros and 0.025. 4 zeros. Woof. Sweet. So this is going to give us a radius of 7 thousandths. All right. I was 99% sure that was correct, but just to make sure there. It gives us a hypotenuse or radius of 7 thousandths. We double that. That's that 14 thousandths right here. So why did I go through all that mess? it corresponds, if you're setting up a machine tool, to plus or minus 5 thousandths. So when you're looking at a drawing, diameter tolerance, it's great for engineers and design or whatever, but when you're actually thinking about like, what machine, can I use a bandsaw or do I need to use something a little more accurate? Like, how much time do I need to spend, indicating something in? This is the language of the machine shop, plus or minus. That's going to be a really helpful number. So if you can look at a drawing and say, 14, 15, 13 thousandths, diameter tolerance zone, that's plus or minus 5 thousandths ish. Now, you'll hear people say, "Whoa, that's not correct because you have all this tolerance zone here." That's why I say ish, right? It's not a rule of nature or anything. It's a helpful way to remember what's going on. Yes, there is a chance that your part is going to measure, plus 6 thousandths in X and plus whatever, plus 0 and Y, in which case, yes, it's going to be right here, and that would be good, even though it wouldn't be good to plus or minus 5 thousandths. That's not the purpose of this. This is just to break down these diameters into helpful, plus or minuses for speaking in English to people, stuff people are going to understand. So 14 thousandths corresponds here. So I'm going to use I forgot what this is called in math, the squiggly equal sign, plus or minus 5 thousandths. Let me use a better color. Squiggly equal sign, plus or minus 10 thousandths. Squiggly equal, plus or minus 20 thousandths. A little squiggly. Plus or minus 0.025 thousandths. So when you get a position tolerance zone less than 7 thousandths, it really gets difficult, right? Plus or minus 2.5 thousandths is very small, obviously, right? So if you're taking from a drawing, right, that has locations that are plus or minus 5 thousandths, and you put in the feature control frame, right? If you're like, okay, the drawing said plus or minus 5 thousandths, so I'm just going to put 5 thousandths for the position tolerance zone. It is very, very expensive to do it that way. It's not really necessary to do that, right? You want to kind of figure out what's going on here, and that's going to bring me to my next point here, right? So what if my drawing does have plus or minus on it, right? And I want to convert it to position. Well, there's basically two ways to do it. And, feel free to put in the comments if you know a better way, or one is like way superior to the other. But essentially, there's let me get rid of some of this. All right. So say our drawing has location tolerances of plus or minus 5 thousandths, right? That's going to correspond, right? So the drawing has got this, right? It's basically 10,000 square tolerance zones. If we just take what I've been saying, right, a 10,000 square, and we fit a circle around it like this, we inscribe the square. I hope that's the right term. It's either inscribed or circumscribed. I think it's inscribed. We inscribe it, right? We're going to end up with a diameter of 14 thousandths, right? So we just put that in our feature control frame for position. Now, that isn't the way you're always going to want to go. Why? It's non-conservative, and that the original design limited to this square, right? And your first thought they didn't know any better. They didn't have GD&T back then. Maybe they did. Maybe this was really a part of their design, right? That it couldn't move in the left and right or up or down as much. So this area, right, is extra that you're adding in when you do this conversion. So the more conservative way to do it is to say, okay, we're switching to position, but now we're going to put the diameter inside of the square tolerance zone. In this way, you're not adding any additional tolerance that the original design didn't have. So in this case, our radius is going to be 0.005. So we're going to say conservative, right, diameter of 10 thousandths, right? So we lose out, but, you know, still better than having a coordinate dimensioning scheme, you know, in my opinion. In most cases, not all cases. Okay. So yeah, that's essentially. Oh wow, it's already been 35 minutes. That's essentially how I would go about that, right? You've got the this way and this way. Either of them is fine. You'll want to find the correct datum reference frame. So say we were going to convert this part to GD&T was. It looks to me the datum reference frame for this, right? I would probably pick this back side to be the primary datum. Probably, I'm not exactly sure how. You know what? Let's skip this top part. Let's do the bottom one, right? And let me get a better color. I would probably pick actually, I would pick this side. You know what? Oh man, I can't make up my mind, guys. Okay. What I'm hung up on is I see these counter bores. I'm trying to figure out how it works. So I think this is going to bolt up to something. So I'm going to stick with this side. So I want the side that's pressing up against something else to be the datum, not the side we're drilling the counter bores through. Oh, let me take a second and do the chat real quick. Okay. All right. So hi, everybody. I see a couple people that have been tuning in. Like I said, I've only been doing these for a few weeks, and I plan on doing it next week as well. Someone in the group is wondering to one-on-one. Yeah, I do blueprint interpretation, see what's a consultant. Yeah, I do consulting. Just shoot me an email. I love tuning in these great content. Hey, Detroit. All right. Yeah, I know what you're saying here, Jason. Yeah, these views are really weird. Like, I don't think that it's almost like it's first angle. I'm just kind of trying to gloss over it for now. plus or minus 5 thousandths the world. Okay. Yeah, I would think that with computers, right, you wouldn't need general tolerances. Like, I mean, this is a computerized drawing, I'm fairly certain. It's like, why not just take all of this mess and just put it on the dimensions, right? So when they're making the part, they're going to be like, oh, this is plus or minus 20, plus or minus 20. Like, I get it if it's General Electric or whatever, and all you're making are General Electric stuff with General Electric drawings, but it's like not how the world works. Like, these job shops are getting drawings from all over the place. And in the United States, at least, you're not required to have the same general tolerances. So it can really cause problems. Okay, enough of that. Okay, so we're going to, oh man, we're going to go datum A here. Datum B, without any other real information, I would go with the long side. Okay, so why not pick the center plane, right? I know some of you are probably screaming into your microphones. Shouldn't it be centered, right? The part is obviously symmetric. I would say since the original designer didn't do that, right? They have a dimension to all of these holes from one side when they didn't have to, right? They could have omitted this dimension and just put a center line here and it would have been symmetric, right? Without GD&T or anything. So since they included that dimension, even though it doesn't make sense to me, I'm going to kind of just leave it in. same thing with the next datum, right? You could say it's symmetric about, well, actually, no, it's not symmetric about left and right. Okay. So we're going to pick datums A and B, and I'm just basing it off of these dimensions. That's how the designer dimensioned the drawing to begin with. So GD&T wise, we're going to make these basic, right? Get rid of these tolerances. They're all plus or minus 5, anywho. All right, make this one basic, and then I would make this, say, 3 times as well. I think that would make the drawing a little bit more clear. And then, yeah, we're going to come in. Oh, what? We would make these basic as well. Now, here's a pickle. This this one on the, actually, no, this one needs to be fixed too. So here's a potential problem. These holes coming from the corners, if we want to make it GD&T legit, we'd either have to change this dimension or make this dimension basic. And let me use a different color. So what I mean is this needs to be basic if this is basic, because the basic dimensions have to lead back to our datum. What we could do if we really just wanted to locate this surface with a plus or minus dimension, say we're using 2009 or something earlier, I could get rid of this dimension here and just have it come off of our datum like this. That would be fine. Or I can make this basic and keep that 0.5. It's got to be one or the other. Ideally, I think, what I would like to do here is leave it dimension the same way. So make this basic, and just slap a profile to A, B, and C on that surface. Just control the profile. Let me go there. Okay. Let me check this. Okay. Huh. Oh, is that not working? Oh, these are all from YouTube. Huh. Hold on, guys. I'm just making sure the... Oh, maybe the LinkedIn one didn't work. Oh, well, whatever. Okay. Yeah, and then we just come in with our position. In this case, for these 3 holes, and I don't even know where they're dimensioned here, right? Some kind of diameter, plus or minus something, position, diameter of something. And since these are plus or minus 5 thousandths, we make all of these a diameter tolerance zone of 7 thousandths. Huh. Oh, okay, that's working. Cool. Oh, maybe that's it. Yeah, let me know, guys, on LinkedIn if it's working correctly. It's telling me that LinkedIn doesn't like 60 frames a second. It looks like my bit rate is kind of clocked out. So let me know if that's working at all. If it's not, I'll try to fix it for next time, or I'll just switch over to YouTube there. Okay. So we're at 40. Wow, that time really flies, right? We're at 43 minutes. Let me see if there's any questions. This is about all I want to cover here. And then I'll save these drawings for next time. I've got a couple drawings, again, that I found just laying around. So we'll take these and make them GD&T and talk a little bit about drafting. I think overall they're pretty good, but there's some things I would adjust on here. 20 years of built up drafting sarcasm. Yeah, you know, I really enjoy drafting. I like making drawings. I like talking about drawings. I wish I could do it more. And that's one of the reasons I do these, starting to do these live streams. It gives me a chance to talk about this and, get other people's opinion as well. I know there's lots of people out there that, do this for a living, and lots of people that know a lot more than I do about it. I just have the opportunity to kind of, talk about it. Okay, so I'll leave it there. All right. Huh. Oh, man. Why did that not work? So it shows it works here. Okay, guys. Yeah, I don't see any questions in the chat. So I know I put till 6 o'clock, but that was kind of just get building in some time for questions there. So if there's nothing else, I'll be getting out of here, and I'll meet you next week, same time. And again, I'm trying to do like a Friday at like 9 o'clock in the morning to catch IST time, and then Europe as well. Yeah, so the next one, 5 o'clock Monday. Yep. And feel free to send in questions. You can shoot me an email or direct message on LinkedIn. If you have a question, if you have a drawing, nothing covered by an NDA or something, but you have like drawings from college laying around, something that don't matter, feel free to send it to me, and maybe I can, talk about it. Oh, interesting. Yeah, when do you think AI will disrupt the GD&T world? I don't know if it'll disrupt it for sure, but as to how much, I always think about when I was a kid with Windows 95, they had all these they weren't called apps back then, but there was like a ape or something that would like hang around in the corner of your screen, and you could click on it and be like, have the thing do a task for you. But it was always so much more work to try to use these like workarounds and stuff. Like, think about people that walked around with Palm Pilots. Like, was it really worth it to use that, or just easier to write it on a piece of paper? So I think it's going to be a while before AI really takes over making drawings. Maybe it'll help. Microsoft Word is definitely better than writing stuff on paper, but I think it's just going to be an assistive tool for a while. Hopefully get rid of like some of the boring stuff. Like, it'd be sweet if AI could go in and, change little stuff and fix spacing and remove some of the quirky features of SolidWorks. But I think drafting, designing, all that's going to be a trade for a while. Yeah, feel free to send drawings in. Just make sure they're not, they're okay to be released to the public or whatever. Or cut the title block out, whatever you got to do. Yeah. If you have, like I said, any drawings you have that you're willing to share, send, even if it's just a clip of a view or whatever. And I don't know if I've seen that many drawings from China. It's normally I hear about, we send drawings to them, and it's just like a total mess as to what actually gets made. F-size sheets, really? Oh wow. I always thought of that as like the hipster the sheet size. Like, why would you use that willingly? Just go to E size or use C. Like, so such a weird size. Like, I guess maybe if you have a printer for F size, but nobody does. Like, they're all just regular printers. So I never really understood what that was for. And I'm sure I'll get a comment in some industry. It's like the standard for whatever, but it doesn't make any sense to me. Okay, guys, I'm going to shut down the stream here. If you sent a question in the last 20 seconds, I won't see it before I shut this down, so I'm not ignoring you. It just won't come through. Feel free to comment on this video, send me an email, whatever, DM for topics for next time. So thanks for joining. I hope you got something out of it.